The next review piece that we're going to move on to is the idea of functions and relations. So a relation is anything that can be graphed using an x and y coordinate. So every ordered pair is showing a relation. It's a relationship between an x and a y. You can also show these as mapping. We don't quite often, but sometimes people find it easier to understand what a function is from this view. But these just come out as ordered pairs. So for example, 9 maps to -5 would give you an ordered pair 9, -5. 9 maps to 5 would give you an ordered pair 9, 5. And then 2 maps to 4 would give you an ordered pair 2, 4, right? So it's just a relationship between an x value and a y value, or an input and an output. You can also graph relations, just using ordered pairs and then connecting the dots. A function is a type of relation where each x value yields only or exactly one y value. So you know how there's like a difference between a rectangle and a square? But technically a square is a type of rectangle. Same idea here. You've got relations, which are your rectangles, and then you've got your functions, which are like your squares, which are a type of relation. So relations kind of like the umbrella term, and then in your relations you have a specific relation where every x value only corresponds or maps or gives a y value and only one y value. So for example, the -6 only maps to 36, whereas up here, the 9 matched to -5 and 5, and that was okay. There's a relationship, but this is a functional relationship. Every x value or every input only gives you one output. In the ordered pairs, what you're looking for is that every x value is only written once. Doesn't matter if y values are repeated, it's just that the x values can only be written once. From a graph perspective, again, you can graph functions by plotting points x and y. And here's the biggest difference between a relation graph and a function graph, is that if you draw a vertical line through the graph, to be functional, you can only hit the graph once. So for example, if I draw a vertical line here, I'm only hitting the graph once. If I draw a vertical line here, I'm only hitting the graph once. There's nowhere that I can draw a vertical line and hit the graph more than once. Versus here, if I do a vertical line, I hit the graph 1, 2, 3 times. Even though it passes the vertical line test here, I only pass the graph through once. If you fail anywhere, you're done. Right? So if you ever have a place that your vertical line hits more than one point, you are not a function, you are a relation. So first thing I'm testing you on is using the vertical line test. Which of the following are functions? So if you look at this first one, if I draw a vertical line, fail. This is not a function. So some people will write, hey, this is a relation. Some people will say not a function, right? This one, what do you think? Function? Right? There's nowhere I can draw a vertical line and pass through the graph more than once. Then I threw this one in just to get you used to this idea of closed circles and open circles. So when you look at this, it's functional, 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 functional. What the heck is happening here? Well, I have an open circle right above a closed circle. An open circle means the graph does not exist there. It goes everywhere up to there, but not there. So even though I'm drawing a vertical line here and it looks like I'm passing through 2 points, one of the points doesn't exist, right? It's almost like a ghost. So you've got yes, a point, not a point, not a point, yes, a point. So this is actually a function. Now, the reason we care about this whole thing about things being a function is that, as we learn on the next page, as soon as something is a function, we can use function notation for its equations. So what we're going to look at is, from an equation standpoint, what equation defines a function, or how do you determine if an equation defines a function? Well, I said that the definition of a function is something where every x value only yields one y value. So for example, if we pick a random x value, let's pick x is equal to 3. And let's pick, because I'm going to use the same x value for the next one. Let's pick 9. Okay, and I plug 9 into this equation. I get y equals 9 squared minus 3, which is going to give you 81 minus 3, which is 78. That x value of 9 only gave you one y value of 78. In fact, no matter what x value I choose, I mean, I chose a pretty awful x value there, but I wanted that for the next one, is that no matter what I put in for x, it's always going to give me one result. Versus in the next equation, if I put in x is 9 and I go to solve for y, What value squared gives me 9? Well, 3 and negative 3. That x value of 9 gave you a y value of 3, but also a y value of negative 3. And that's not a functional relationship. So this one would be a relation, but not a function. Whereas this one would be a function. So again, like I said, who cares? Well, math cares. Math people are lazy. They want to write things in the easiest way possible. And by changing our y into an f of x, which is called function notation, it allows us to be lazy. It allows us to give you a question where it says, hey, f of x is this. Plug in x is negative 7. Plug in x is x plus h. Okay, so let me just explain that further. Regular notation is something like y equals x squared minus 9x minus 12. For me to ask you to put in an x value of negative 2, I'd have to say, find the value of y when x is negative 2. And we'd plug in negative 2 and we'd solve for y and we'd say, when x is negative 2, the value of y is 10. Or we could give an ordered pair, right? Negative 2, 10. But in function notation, instead of having our equation be y equals, we let our equation be f of x equals. So this is read f as a function of x, or f at x. And what it says is that I can put anything I want in for x. So for example, I can put in negative 2. So I could say find the value of your function at negative 2. And everywhere there's an x, you're going to replace it with a negative 2. Again, I get 10, but now I could display my answer like this. And I could read this as the value of my function at x is negative 2 is 10, which sounds like a really long sentence, right? Maybe it's better to say this, but it's quicker because nobody ever writes the sentence. People write this. So if a function f is given by f of x is equal to 2x squared minus x plus 3, and I ask you to find f at negative 7, I'm asking you to find the value of the function when x is negative 7. In other words, what's y when x is negative 7? So to do that, everywhere there's an x, you plug in a negative 7. Watch your integers. And then we simplify. This would be 2 times 49. Again, if you're calculator efficient, do not write all these steps. And then we get, what is that, 98 plus 10, 108. I never trust myself. 2 times 49 plus 7 plus 3. Ah, look at that, 108. So the value of my function at negative 7 is 108. In other words, there's an ordered pair, negative 7, 108 on the graph of this function. We can also get you to put random hard things in for x, and I swear this is just to test your ability to deal with algebra. So again, anywhere there's an x, you're going to put in x plus h. So my equation is 2x squared minus x plus 3, and everywhere I put the bracket, I'm going to fill it with an x plus h. So instead of x, I'm using x plus h. Now, pause the video. Try to simplify this without making mistakes. So for me, I'm going to write it out as x plus h times x plus h. It's the biggest mistake people make. I'm going to distribute my negative. Now I'm going to distribute my bracket. So x times x is x squared. X times h is xh. H times x is, I'm going to write in the same order, xh. And then h times h is h squared. Some people like alphabetical. I don't know why I wrote the x first. And then we have minus x minus h plus 3. And then distribute. Now I'm going to collect like terms before I distribute. So I have two like terms in the middle there. So I'm going to go 2 times x squared plus 2, again, hx, xh, it really doesn't matter, plus h squared minus x minus h plus 3, and then I'll distribute the 2. So I have 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Holy Toledo. And again, treat this as like a, can I keep myself organized? Can I prevent integer mistakes? How am I doing? Double check that you can't simplify by collecting like terms, but that is the answer. The last thing we can do is, instead of giving you an equation that defines your function, we can give you a picture. And I could say again, find the value of your function at 0. They're giving you the x value of 0 and saying, what's the y value when x is 0? Well, x is 0 here, and the y value is -8. Same thing at 2. The x value is 2. What's the y value? 0. Pause the video, give the last one a try. And hopefully you got -3. When x is 5, y is -3. Awesome. Now you're ready to do your homework on functions on page 29.